my students, how are you? Now see, today our topic is arc of a circle. What is an arc of a circle? Okay. Now see here, this is a circle. If a secant intersect it, okay, suppose this is the secant, this intersect it, then it divides the circle into two parts. Here, divide the circle means you can take it as the circumference of circle. It divides the circle into two parts, and here any one part and the point common to the circle and the secant forming an arc. It constitutes an arc. Here, suppose if I am going to take a point over here, suppose this is x, and here a point that is y. So that what happens, if I want to explain you that arc AB, then what happened, that AB can be from this side or from this side. Okay, therefore it's better to express that AXB. It means only this arc. Okay, so here the arc AXB, one arc. Okay. Second arc AYB. AYB. Now see, if suppose this is the center of the circle represented by O, then you can see on this part of the circle the center line. Okay. Therefore, the arc on which side the center line is called the major arc. Is called the major arc. And the other side of the arc is called the minor arc. Means this arc does not contain the center of the circle. Okay? Understood? Therefore, here the definition of arc, you can say the secant divide the circle in two parts, any one part along with the common point of the circle and the secant constitutes arc. Okay? That I am going to write here the definition, how you can define an arc, that I am going to write here. Okay? Therefore, arc, here I am writing a secant divide a circle into two parts, then any one part along with the common point of circle and secant constitute an arc. Okay. Therefore, any one part, here suppose this is part of the circle and these 2 points forming an arc. Therefore, there are 2 arcs. Now see the definition of major arc. How you are going to define a major arc? The arc on the side of center is called major arc. Okay, and now after this the minor arc. The arc on the other side of center is called minor arc. Okay, this is the definition of major arc and the minor arc. Okay, now after this one more thing, that is the, you can say, the central angle. What is central angle? Here I am going to draw first a circle so that I can explain it in a better way. Let's point here. This is the center of the circle. Okay. Now see, telling that if the vertex of a angle is on, if the vertex of an angle is on the center of circle, such angle is called the central angle. This is the central angle. Why this is central angle? Because its vertex is at the center of the circle. Okay? Therefore, if the vertex of an an angle is center of a circle, such angle is called central angle. Okay, such angle is called central angle. Okay, now see, I am telling you about the central angle, because central angle also divide the circle into two parts. Now see, if you see here, this is the one part, and second part I am going to show you with another color. This is the another part. Means central angle also divide the circle into two parts, and here this angle, which is means this angle is called the minor angle. Okay, because this arc does not contain the center, and here this arc which contain the center, therefore this is the major arc. Okay, this arc, see the arc here, this arc does not contain this center, therefore this is the minor arc and this is the major arc. Okay, now see here, this arc can be better explained in the terms of its measurement, means measure of arc. Here is a relation with the central angle and the measurement of arc. Therefore, here I am writing the next topic, measure of arc. Now see here, there is a relation that the measure of minor arc is equal to its corresponding central angle. Now see, the measure of minor arc is equal to its corresponding central angle. Now see here, if the measure of the central angle is 45 degrees, then the measure of this arc is also 45 degrees. Measure of arc is in the degrees. Okay? Now see, this is for the minor arc. Here the measure of is equal to 360 minus minor arc. Sorry, 360 minus measure of minor arc. Okay. If suppose this is represented by theta, then this will be 360 minus theta. Theta means if here you will take, that is 45. Okay. Now after this, measure of semi arc. Measure of semi arc. Semi arc means that is the semicircle. Arc of a semicircle is how much? 180 degree. And then measure of complete circle how much? Measure of complete circle, any one of you? Yes, 360. Okay, means by this method you can find out the measure of, by this only you can find out either the measure arc or that of the minor arc. Okay. After this, the topic is your congruent arc. How you will define a congruent arc. Now see here, I am writing here congruent arc. Here I am going to draw two circles. Suppose this is one circle. I am going to draw another circle. This is the second circle. Suppose both of them are having one center, and I am going to show that having the same center. Okay. Now, if I am going to draw a central angle over here, if suppose I would like to draw a central angle like this, suppose this is the central angle. O, here suppose this is your A and this is your B. Here, this is your C and this is your D. I am going to now see here. If the measure of the central angle is 45, then what happens? Measure of arc here. Measure arc, which one? CD. Will be equal to 45, and measure arc AB is also equal to 45. Then it means that arc CD is equal to AB, or arc CD is congruent to AB. No. See here. If here in such case the arc is congruent if its measurement and radius of the circle is same, equal. Not only measure but also the radii. Okay? Means if I am going to draw another, see here like this, I am going to draw another angle, and suppose this angle is also that of 45, and here this is suppose BF. Then what happened? Because here this is the same circle and its measure is equal to 45, then we can say measure arc AB is congruent to measure arc BF. Why? Because its measurement is same and the radius of the same circle. Okay? Therefore, here for congruency of arc, the measurement of arc and its radius must be equal. Okay? That I am going to write here. First I am going to erase it and then I am going to understood. Now see, if the measures of two arcs and its radii are equal, then the arcs are said to be congruent. Okay? Understood? If the measure of two arcs and its radii are equal, then the arcs are said to be congruent. Okay? Now, see, after this, the next topic is property of sum of measure of arc. Property of sum of measure of arc means how the two arcs can be, means their measurement can be added. Here I am going to draw another circle. Suppose this is a circle here. Okay? And here arcs are represented. Suppose this is a point A, here point B, here point C, D, Okay, this is the center of the circle. Then if you will see, there are two arcs A, B, C and C, D, E. These are the two arcs. And in these two arcs, this point C is common. Then you can add these two arcs. Means the sum of measure of two arcs can be done when and only when there is a common point. Okay? When there is a common point. Okay? Then here I am writing the measure of two arcs and measure of sum of two arcs. The measure of sum of two arcs can be done only when only one point is common between them. Okay? If there is only one point which is common, then only the measurement can be done. Here, see, this point C is common, therefore we can write here, if we will take AC sum of, means measure arc ACE is equal to measure arc ABC plus measure arc CDE. Okay? The arc can be measured when and only when there is a common point. If there are more than one common point, then sum of the arc cannot be found out. Understood? Okay. After this, there are two theorems. Here, first theorem, that is regarding the congruent arc. That is regarding the congruent arc. Here I am drawing a circle and suppose the center is O and here an arc AB and another arc here, suppose this is P and Q. Okay? If this measure of these two arcs, suppose measure of this arc, suppose this is of 50 degree, and this is also of 50 degree. Then the chord corresponding to it. Now see here. Sorry. Then the cards corresponding to it. Suppose this is one card. And another card is this one. Okay? Because these two arcs are congruent, then what happens? These cards will be congruent to each other. This card is congruent to each other. Therefore, here I am writing the chords corresponding to congruent arc of a circle, congruent arc of a circle or congruent circle. Okay? Circles are congruent. Okay? Now see, if the arcs are congruent, then the corresponding chords should be congruent. Its proof is already given in the textbook. Now the next theorem, second theorem. Here you can say it is converse of the first one. The corresponding arcs to the congruent chord of a circle or congruent circle or congruent. Here I am going to draw again another figure. See here, suppose this is a circle, okay, and if two chords, here the chords are congruent here given. If two chords, here one chord, and I am going to take its copy, okay, I am bringing it towards here. Then what happens? These two chords are congruent. Here I am writing, this is suppose AB and this is your CD. These two chords are congruent. Here given the corresponding arcs to the congruent chords or congruence of a circle or congruent circles are congruent. Then if these chords are congruent, then this arc will be Okay? If these chords are congruent, then the corresponding arcs are also congruent. Using these properties and theorem, we are going to solve the practice set 3.3.